Hi guys, today we'll solve this problem which says that we have the function of this wave and we have to calculate the average rate at which the energy is transmitted, and is also asking us for the energy contained in one cycle. So the average rate at which the energy is transmitted is described by the equation of power, which is a half of the linear mass times the angular velocity times the amplitude squared and times the velocity. The angular velocity also goes squared. We have some of these values in our equation of the function, and there are the angular velocity, we already have it, and the amplitude. First of all, we have to convert the units of the linear mass into kilograms per meter squared. And also we need to know what is the velocity, but we already know that the equation of the velocity is lambda times the frequency. So we don't have these ones, but we have another definition of this equation, which is the angular velocity divided by the number of the wavelength, which is 3 pi, and we have already in our equation. So that gives us 10 meters per second. Now we only have to substitute all those values in our equation. And this give us 15.11 watts. Now we have to remember the first definition of power, that is, or the average rate, that is the energy elapsed in a period of time. And they are asking us now for the energy contained in one cycle at a certain time. So the problem is asking us for the energy, so we only have to isolate this from our equation. But what happens with time? We have to recall another equation, that the angular velocity equals to 2 pi times the frequency, or divided by the period, which is the equation that we need. And from here it's easy because we already have the angular velocity and we only have to substitute that in our isolated equation of the period. And this will give us 1/5 of second. So we only have to substitute those values and we'll get the energy contained in one cycle. So the energy is equal to 3.0 joules per cycle.